Good evening, students. Once again, I am here with maths. And see, in the previous video, we have done one or two sums from the previous section where we were finding the points of discontinuity. And I hope you people have done till sum number 16, right? And now we will be discussing one or two sums from sum number 17 till sum number 23 so that you can do your sums. See, in sum number 17, it is given we have to find the relationship between a and b when the function is continuous at x equals to 3. So what we will do here, since it is given the function is continuous, it means the left hand limit at x approaches to 3, right hand limit when x approaches to 3, and f of 3 all will be equal. And when you equate these three things, you are getting two equations. And when you solve these two equations, you will get the values of a and b. So you will be able to get that answer. We will discuss here sum number 18. So we will start here with sum number 18 only. This is exercise 5.1. Sum number 18 we will do. In sum number 18, we have to find for what value of lambda, what will be lambda, so that the given function, first of all, it is continuous at x equal to 0 and then continuity at x equal to 1 also. It is given lambda into x square minus 2x for all x less than or equal to 0 and 4x plus 1 for all x greater than 0. Now when we check the continuity at x equal to 0, this is the first part of the statement. What we will find, since x is less than 0 also, x is greater than 0 also, and x equal to 0 also given. It means when x is equal to 0 or when x is approaching to 0 from left hand side, we have one function. X approaches to 0 from right hand side, we have this function. So no doubt here we will find LHL and we will find RHL, right? So when we find LHL, it will be limit x approaches to 0 from left, the function, and it will be limit x approaches to 0 from left, the function is lambda into x square minus 2x. See, lambda is constant, it's a constant in sense it is independent of x. So whatever be the limit, it will not affect the value of lambda. So lambda as such, and when you apply the limit, it will be 0 minus 0, that is 0 equal to. And when I apply the limit here, limit x approaches to 0 from right f of x, what we will get here, it will be limit x approaches to 0 from right, and the function is 4x plus 1. Let us apply the limit here and it will become 4 into 0 plus 1, which is equal to 1 only. And the next thing, we have to find f of 0 also. Now here we have x less than or equal to 0, the function is lambda into x square minus 2x. It means in order to find the value of the function, once again we have this only, it will be 0 minus 0, so this is 0. So what is happening here, LHL is not equals to RHL and RHL is not equals to f of 0. So what we will say, so what is happening here, first of all the function is discontinuous at x equal to 0, but the question is for what value of lambda the function is continuous. So what we will say here, whatever be the value of lambda, or will it affect that continuity, will it affect the continuity of the function if I put different values of lambda? No, it will not. So what we will say, no value of lambda, or for no value of lambda, function will be continuous at x equal to 0. There no value of lambda can make this function continuous, because LHL, because we have x square minus 2x minus x, so whenever you put x approaches to 0 here and whatever be the lambda, ultimately this term will make lambda into 0 or something into 0 always 0. And here since the second expression is independent of lambda, so here whenever x is approaching to 0, 4x plus 1, it is always giving you 1, right? So what is happening, the function will not be continuous, and the question now, what will be the value of lambda so that it is continuous? For no value of lambda, the function will be continuous. Now the next part that we will be checking when we have to find the limit continuity at x equal to 1, the second part of the sum. Now at x equal to 1, 1 is greater than 0, no doubt. But we have the function for all x less than 0, this function, and for all x greater than 0, we have one function. Now since x is equal to 1, that means, and for all x greater than 0, we have only 4x plus 1. So what we will be doing, when x is equal to 1, we are finding the limit. There is only one function and the function is 4x plus 1. So when I apply the limit here, limit x approaches to 1 f of x, it will be directly answer we will get here 4x plus 1. So 4 into 1 plus 1, that is 5. And when I find the value of the function, this will also be 5, because in the same function 4x plus 1 we will put x equal to 1 here. And here what will happen, when I check the continuity at x equal to 1, the function is also always continuous. Not only 1, whatever, for every value of x greater than 0, it can be 1, 2, 3, 4, till infinity, whatever be the value of x, the function will always be continuous. Reason being, there is only one function for this particular sum, right? So here what will we say, for any value of lambda, because this part is independent of lambda, so it has no connection with lambda, so whatever be the value of lambda, it doesn't bother this function. So we will write down, for any value of lambda, function is continuous at x equal to 1, right? So this is how we will do the function, this is how we will do this sum. For when we check the continuity at x equal to 0, it is not continuous for any value of lambda, and when we check the continuity at 1, it is continuous for any value of lambda. So this is how the sum will be done. Similarly, you people can do sum number 19, where we will be using the definition of greatest integer function, right? Sum number 20, 21. I will discuss one more sum from sum number 21 or 20th we will do, so that you can do these triggers functions as well. So that I will discuss in the next video. I hope this sum is clear how will we be doing. Sum number 17 you can do, sum number 20 we will discuss, and rest I will discuss in the next video. Okay.